In this mystery solar system question, we're applying the ideas of planet formation to our mystery solar systems. We're looking at the largest planet in the inner part of the solar system and the largest planet in the outer part. Effectively, what you want to do here is talk about how these planets formed based on our model of solar system formation. For this, you'll have to review the steps in solar system formation and talk about how these lead to planets of different sizes and compositions. You need to start by looking at the data you have for these planets. There are 3 pieces of information you should be looking at for each planet: the mass, the distance from the star, and the density. The first 2 of these are right on the table, so you can simply list them as they're given. But don't forget the units. The density is something we calculated in a previous question, so you should use your answer there. Remember that if you made any mistakes in those calculations, you will need to correct those values first. Feel free to ask if you have any questions on making those corrections. All 3 of these pieces of information will be important in your answer, so you should think about what they're telling you. The distance tells you what part of the solar system the planet formed in, assuming it didn't migrate much. Remember that different materials condense in different parts of the solar system, so the distance can tell you if the planet is inside the frost line or not. The density tells you what sort of materials the planet is made of. Remember that if the density is high, meaning 4 to 6 grams per cubic centimeter, then it's made of mostly rock and metal. If the density is low, typically 0.5 to 2 grams per cubic centimeter, then it's mostly made of lighter materials, such as hydrogen compounds and liquid hydrogen. Remember that the lowest possible densities for planets are around 0.5 grams per cubic centimeter, while the highest densities are around 6 grams per cubic centimeter. If your density answer is well outside of that range, you'll need to go back and check your calculation. The most important thing the mass tells you about formation is whether or not the planet got big enough for gas accretion. Remember that planets that get to 10 Earth masses can go through rapid gas accretion, while smaller planets will have no more than a small amount of hydrogen. Now let's look at the steps in solar system formation. If you've done the solar system formation flowchart, that can help guide you as well. Remember that the major steps are contraction, condensation, solid body accretion, gas accretion, and cleanup. Since we're looking just at the planets themselves, we're not so worried about the cleanup phase. Contraction is the same for any planet, since it just gives the star with a disk around it. It's the middle 3 steps where your description will be different depending on the type of planet. So remember that in the condensation phase, different materials condense in different parts of the solar system. You'll want to describe which materials condense to form these 2 planets based on where they're located. The density can help support your conclusions here. For solid body accretion, you'll need to discuss how this is different in the inner and outer solar system, and how big the planet gets from this. If the planet is big enough to go through gas accretion, then you should explain how you tell and how much gas this implies the planet is made from. As you're doing this, make sure you make clear how the data from the mystery solar system table gives the evidence to support your conclusions. It's not enough to have a list of data in one place and then a list of conclusions later. The data is the why part of your conclusions, so it should be part of your discussion.